Heterolytic bond fission. What is heterolytic bond fission? Heterolytic bond fission gives rise to a positive ion and a negative ion. In such kind of cleavage, both the electrons of a bond are taken by more electronegative atom. For example, if I show you, I have a molecule say HCl. Here chlorine is more electronegative and hydrogen is less electronegative. So how the bond cleavage will happen? It will happen like this. Both the electrons of the bond will be taken by chlorine. So what will happen is there will be a formation of H plus and Cl minus. So one positive ion and one negative ion, and negative ion will always be formed from the more electronegative atom. So such kind of cleavage is known as heterolytic cleavage. So heterolytic cleavage gives rise to a positive and negative ion, whereas homolytic cleavage gives rise to free radicals. So the more electronegative ion will always gain negative and less electronegative will gain positive after the bond is broken. Alright. So this is what happens in a free heterolytic cleavage. Now we are going to discuss different kinds of intermediates. What are these? Carbocation, carbanion, free radical, carbene, nitrene, benzyne. So we have different type of intermediates formed during reactions in organic chemistry. So we will be studying about each of these in detail. Let's see. Carbocation we have picked up firstly, and where does carbocation forms? There are multiple organic reactions where carbocation intermediate is formed, such as it is a reaction intermediate in SN1, it is a reaction intermediate in E1, it is a reaction intermediate in Friedel-Crafts alkylation, and so on. Many reactions have carbocation intermediate. Here, what does a carbocation intermediate looks like? A carbocation intermediates have sp2 hybridization, such as this. So the shape of a carbocation is trigonal planar. Shape is trigonal planar, and you can see here there are total of 3 bonds. So number of valence electrons in a carbocation equals to 6, and the shape is trigonal planar. What is hybridization? Hybridization of a carbocation is sp2. Hybridization is sp2. So that is all about carbocation. And what does increase the stability of carbocation? More is resonance with carbocation, more will be stability. More is hyperconjugation, more will be stability. For example, if I ask you, I have a carbocation like this, and I have another carbocation which has something like this structure. So what do you think? Which one will be more stable? You have to see which phenomena is happening over here. Only hyperconjugation. This one has 3 alpha hydrogen and this one has 6 alpha hydrogen. So the number of hyperconjugating structures in the above one is 3, and in the lower one the number of hyperconjugating structures is 6. So more the number of hyperconjugating structures, more will be stability. So the second one is more stable because it has more alpha H, so it will have more hyperconjugation. So this one is more stable. Alright. So you can compare depending on which one has greater alpha H. For example, tertiary butyl cation. Tertiary butyl cation has in total this is alpha, this is alpha, this is alpha carbon, and all these hydrogens attached to alpha carbon as alpha hydrogen. In total, tertiary butyl cation has 9 alpha hydrogen. So it has extensive hyperconjugation, so it is very stable. So carbocations can be explained on the basis of stability depending on which phenomena it is showing. So what are the factors? More is aromatic character, more stable, then resonance, then hyperconjugation, and the last is inductive. So whichever is dominating, we will compare the stability from there. Alright. So here orbital structure we have discussed, and the shape I have explained it to you over here. Alright. We will be discussing more further. Thank you.